Hi, I'm Christian. In this video, I'm going to be showing you how to make a SolidWorks assembly of this 1-pound plastic drum ant. Now in this video, you're going to be learning some basic mates, advanced mates, and just the general features that an assembly has to offer. So let's jump right into it. So the first thing you're going to want to do is go to the new in the top left and create a new assembly. Once that loads up, it'll automatically bring up your insert component and a file library. So for me, I need to go find where all my parts are located. You can find the download for this folder in the description of the video, and you just need to select every part you want. So in this case, it's everything except for the final assembly. And then remember to click this push pin in the top right, because if you don't, it'll just close the window every part you have. Then you just need to left click to place the motors. For this, we're going to need 2 motors, one side plate, one rear plate, another side plate, 2 wheel hubs, 2 wheel guards, and 2 fat wheels, 1 front plate, and finally the drum. So what you'll notice is that almost all of these parts move around a bowl. They're not fixed in place, except for this motor, which means if I try to drag this, you can see it's fixed. The reason this is because when you start an assembly, the first part you place will always be fixed. That way the assembly has a reference point to go off of. Now this can be changed. Say I want this motor to be the base point. I just click fix, right click on this one and click float. So now this one can move, but this one can't. In general, it's always a good idea to have one part of an assembly fixed at all times. That way it stays completely constrained. So, first thing you're going to want to do is start by just mating a side plate to this motor. The mate tool is how you relate 2 objects in space in an assembly. It's located right here. It's a little paper clip. And when you first open it, it's a little assaulting. There's lots of different options: standard mates, advanced mates, and mechanical mates. Mechanical mates are more just for fun, making things so when you turn one gear, it turns another gear. Advanced mates, similar. There's only one here that I find myself using very often. And standard mates you will use constantly. So let's start off just by putting these wheel hubs inside of the wheels. Now when you do this, it's going to automatically select the most applicable type of mate. So in this case, it's going to be a concentric mate, which means you want the 2 centers of the circles to be coaxial with each other. So once it does this, we could just click the check mark. But you see this little lock rotation button? If you don't click that, it'll make it so that this wheel hub is free spinnable, which doesn't seem like a bad thing, but that can cause a significant amount of lag once you have your final assembly. So since we didn't lock rotation originally, you just exit the mate window, click the arrow here, right click on concentric, and click lock rotation. So now this is physically incapable of rotating. So that's that. Now let's just put the wheel hub inside of this wheel. So go back to mate and just click on what face you want to mate. So I'm going to be pushing this onto here. Now I have one complete wheel. So I'm going to do that with the other one quickly. Make concentric, lock rotation. You can do this all in the left window as well. And I'm going to drag it away so I can see it. And when you select the first object for a mate, it's going to automatically hide it. There is one exception to that rule that we'll get to later, but for the vast majority of mates, that's how it works. So select this face, then same as the other one, select the interface of the wheel hub. And now you have 2 wheels. So now let's attach this motor to a drive plate. Now there is a correct drive plate. There's a left drive plate and a right drive plate. So we're gonna mate this concentrically with the motor. And you'll see right now, because of how this piece is pocketed, it's pocketed on the wrong side right now, meaning it's not correct on the motor. So what you're gonna want to do is click these 2 crossing arrows. Once you do that, it flips itself. Now, there's a reason I didn't lock this rotation, and that's because there are bolt holes on this motor. So what that means is when I'm trying to align it with this piece, I want it to be defined by that rather than just an arbitrary rotation. So now I have this concentric on here, but it still has two axes of freedom, translational and rotational. So what we're going to want to do is select, in this case, these holes don't exactly line up with these mounting holes. That's more because this isn't the exact motor that will be used on the final robot, which is because combat robotics parts, you tend to have difficulty finding exact CAD models, so you have to deal with what you have. So just click this face in the back end of your side plate. This will automatically do a parallel mate. The reason it does parallel, not coincident, is because since we already defined this as being concentric, you can't push this side plate any further in the negative Z direction. That way, SolidWorks determines that it can only be parallel or perpendicular, but that's not what we want. So now, just click the check mark, and we have this drive plate with only one more translational axis of freedom. So to get rid of that, just click for the interface of the motor and the interface of the wheel guard, or the side plate rather. This will automatically select Coincident Mate, so the two planes of these objects will be touching no matter what. Click the check mark, and now you have one side of the robot. So we could do that with this side, but then you would have a floating object in space, and that's not really what we want. You want to start somewhere and move from there. So what we're going to do is put the front plate on. So just click this face and attach it right here. But again, this is backwards. We don't really want our front plate to be phasing inside of our side plate. Not really how physics work. So just click this little flip mate alignment button, check mark, and now it's on the right side, but not the right position. So this face right here and top face, again, a coincident mate. 90% of the mates you're going to be doing are either concentric or coincident. Then, now it just has one more axis of freedom. Select the inner holes here. It'll make them concentric, that way a bolt can go through them. And now, this is fully defined. So if you try to drag it, it'll bring up this window just like this, fully defined. So now, let's put this one in position. Click this face right here, then click the interface rather, on the other side plate, and check mark. So now it has two dimensions of freedom. Click the top of the front plate and the top of the other side plate. Get them coincident, and just like we did on the other one, top bolt hole and top bolt hole. Oh, whoops. So this is an interesting debate in the SolidWorks community of if it's better to use edge mates or face mates. Personally, I would say use a face mate no matter what, but to each their own. Since we accidentally selected an edge here, we're just going to delete it and reselect the face. And since you'll see here, it has coincident selected, so it won't let me reselect this face. But that's an easy thing to fix. Just click concentric and then select the face. And there we go. So now, fully defined. So let's put the back plate on. As easy, just a flat plate. Attach it, one face to the other face, coincident, we're good. Right here to right here, good. And we'll just make the bolt holes instead of the top plane. And there you go. You have the outline of your robot. So let's put this motor in position. Start with a concentric mate going to where it goes. Click the center, lock rotation, rotate. And now click this face and the face on the inside of the motor counterbore. Click the check. And now you have your pretty much complete frame of the robot. So the reason this robot is designed in multiple pieces despite it being 3D printable is because during a combat robotics event, typically parts tend to break. So you want them to be replaceable without having to replace an entire chassis. So that's why you have disposable wheel guards, disposable side plates, and everything like that. So we're going to mount the wheel guard in position, just like these two faces and these top faces. And finally, you'll notice there are two holes inside the wheel guard that we currently can't get to. So instead of selecting the wheel guard first, what we're going to do is, well, what we could do, so instead of selecting the wheel guard first, what we're going to do is right click on this piece, and you could select hide, but hide gets a little complicated because in order to show it again, you have to go into the feature tree, which is more work than is necessary. If you just click the down arrow and select change transparency, the way transparency works is if there's nothing behind it, it will select your part, the transparent part just fine. But if there is a part behind it, it'll automatically select the part that's behind. So in this case, I want to select these circles. So I select the bolt holes and it automatically selects them. And since I need to select this piece where there's nothing behind it, I have to make sure I'm not selecting it like this. Otherwise, I can't select the bolt hole. So just click here and boom. It's one wheel guard in position. But this is still transparent, so to change it, right click, down arrow, change transparency. If you'll notice, 99% of assembly work is done with your mouse. If you're doing distance mates, which we'll get to, then you will need to type something in, but in general, it's not very keyboard heavy. So do the exact same thing on this side. Not going to want to lock the rotation here. And now we have our wheel guards in place. So let's add in our wheels. So click the outside of this wheel and the axle to make them concentric, but we want the wheel hub to be closer to the motor rather than closer to the wheel guard. So lock rotation, reverse, and now it's in the right place. So click this face, but we don't want them to be touching because that'll create a lot of friction. It's not ideal. So we'll just give it about a 32nd of an inch of space. That way, it's not really grinding against the plastic. And then we're going to do the same thing on the other side. Select this. Select here, and it does automatically select coincident, so we're going to need to make it a distance mate. And you'll see it's on the wrong side. But if I select flip mate alignment, you'll see it's still incorrect. So distance mates are a little weird. You're going to want, the correct way to do this is this little plus minus button. It just flips the dimension, not the alignment. So if I click this, it slides it with the wheel hub still being facing this plate. So I'm going to bring that to a 32nd of an inch also. And then finally make it concentric to the axle. Lock rotation. There we go. Now, all we have left is the weapon, a drum. So first things first, we're going to want to make it concentric with its mounting points. So select the inside of it, then select the mounting holes. And we're not going to lock the rotation because we want to see it move. Wouldn't be much fun if the assembly didn't move really. So flip the mate alignment. Now that being said, it not being fun is more just if your computer can handle this little bit moving. But this isn't really an advanced assembly, so it shouldn't matter. Click the check mark. You can still spin. And what we could do is we could dimension the distance so that it stays half an inch or a quarter inch away from that wall, but there's a better way of doing it. And if you remember earlier, I talked about there being only one advanced mate I really use often, and there being an exception to the clicking something in a mate rule and having it hide. That's under the advanced mate tab, and it's called a with mate. Now, what I typically do, I only do the centered constraint because it's the most useful one. And you're going to select first two faces on one part. And now I want this part, the median of these two planes, to be centered with the median of these two planes. So now, if I click the check mark, this will stay centered. I can't drag it side to side. So now, you see right here, we have our drum. So in this video, you learned the basics of SolidWorks assemblies. You learned how to do basic mates, standard mates, and the only real useful advanced mate. Thank you for watching.